China has introduced something new in the AI world, and it is causing a lot of attention. This is not a small update. People usually think of quantum computers as giant machines locked inside research labs, connected to huge cooling systems and costing millions of dollars. But this time, the story is very different. China has developed a new quantum photonic chip that actually works inside real data centers. And according to early reports, this chip is offering a level of performance that sounds unbelievable at first. Some sources claim that this chip can be up to 1,000 times faster than NVIDIA GPUs for specific types of AI tasks. This does not mean it is faster at everything, but in certain areas, the speed gains are huge. What makes this even more surprising is that the technology is not just a future promise. It is already being used in fields like aerospace, biomedicine, and finance, which depend heavily on fast data processing. So let us break everything down step by step and understand what is happening. The chip comes from a Chinese group called ChipX, which stands for Chip Hub for Integrated Photonics Explorer. They partnered with another company called Turing Quantum together. They created what they describe as the first industrial-grade optical quantum chip that can scale. The most surprising part is its physical size. It is not a giant machine filling a whole room. Instead, it is built on a 6-inch thin film lithium niobate wafer that contains more than 1,000 optical components on a single piece of silicon. This method is called photonic integration, where everything is placed together tightly in a small space but still performs powerful processing. The main reason this chip is special is because it uses light for computation instead of electricity. Traditional computer chips use electrical signals, but photons, which are particles of light, behave very differently. Light does not heat up the same way electricity does. Photons also travel faster, lose less energy, and can move through circuits with far less resistance. This means the chip can process information much faster and much more efficiently. This is an important innovation because data centers around the world are struggling with heat and power usage. AI training uses a huge amount of electricity, and companies are trying to find new ways to reduce energy costs. A chip that uses light instead of electricity directly targets this problem. The claim of being 1,000 times faster captured global attention. According to reports from the South China Morning Post and statements from the developers, this chip can accelerate certain types of problem solving dramatically. That does not mean the chip outperforms GPUs in every situation. But for tasks that benefit from quantum-style parallel processing or from extremely low latency light-based pathways, the performance can go far beyond classical hardware. Now let us look at scalability. One of the biggest challenges with quantum hardware is that it is usually large, fragile, and slow to build. A full quantum system can take months to assemble and prepare, but ChipX claims that their new chip design reduces this time by a huge margin. They say a system that once took 6 months to build can now be created in just 2 weeks. A system that reaches near quantum levels of performance in such a short time is a major achievement. This chip is not a full universal quantum computer that breaks encryption or performs impossible calculations. It is a hybrid device that blends quantum and classical techniques to accelerate AI and data processing. It works like a programmable photonic accelerator using the properties of light such as color, phase, timing, and distribution to perform computations. The monolithic design, where everything is placed on one wafer, impressed many researchers around the world. It shows a level of integration that is rare in current photonic technology. The team behind this chip won the Leading Technology Award at the 2025 World Internet Conference in Wuhan. This was not a small competition. More than 400 entries from 34 countries were submitted. Winning such an award indicates that China is ahead in at least one part of the photonic quantum race, especially when it comes to manufacturing and practical deployment. China has already started a pilot production line for these chips. They claim they can produce up to 12,000 wafers per year. Each wafer can create around 350 chips. In standard semiconductor manufacturing, this is not a huge production number. But for quantum photonic chips, it is far more advanced than what most experts expected at this stage. Even though there are still challenges, such as improving the yield and handling delicate materials like thin-film lithium niobate, China now has a full production chain. This includes chip design, fabrication, packaging, testing, and system integration. In comparison, many companies in Europe and the United States are still working on smaller wafer sizes and focusing on prototype designs. Some companies use silicon photonics, and others use indium phosphide, but most of their work is still in research labs. China, meanwhile, already has a functioning production line for 6-inch thin film wafers, giving them a clear head start. While China is moving fast, NVIDIA is also investing heavily in optical and quantum technologies. They understand that data centers cannot continue to rely only on electrical signaling. Power consumption is rising quickly, and training large AI models now cost more in electricity than in hardware. Photonics is becoming essential because photons can carry more information with less energy. Another surprising part of the chip is how easily it scales. The research team says the architecture can support up to 1 million qubits. These are not the same qubits used in superconducting quantum computers, but the design allows multiple chips to be stacked and connected in ways that resemble large GPU clusters. This creates a massive grid of parallel processing pathways, where photons travel through thousands of routes at the same time. The chip also offers other benefits. Because photons do not create heat, the chip stays cooler during operation. Classical chips often slow down due to overheating, but photonic chips can maintain high speeds for longer periods. Photons also allow more bandwidth, more information density, and more paths for signals to travel without interference. There are still many things that need verification. It is not clear how the 1,000 times speed measurement was calculated. We also do not know how the chip performs during long-term usage, but this is normal for any new technology. Early designs often raise questions, and only time reveals the full potential and the limit. What matters is that China has taken the first step toward large-scale photonic quantum hardware industries that require fast data processing are already showing interest. Aerospace companies need high-speed simulations. Biomedicine uses advanced modeling for drug development. Finance depends on fast pattern recognition for trading. These fields feel the limits of classical hardware more than others. Since photonic chips do not need special cooling systems, they can be placed directly into existing server racks and used like normal accelerators. One more technical detail that stands out is the new co-packaging technology used in the chip. The designers placed electronic and photonic components very close to each other on the same wafer. This reduces latency, increases bandwidth, and lowers noise. Shorter travel distances for photons also reduce error rates and improve overall performance. This approach is similar to the trend seen in classical chips, but taken to a much higher level, because light behaves differently from electricity. The announcement came at a time when the United States, Europe, and Asia are all increasing their investments in photonics. Every region is focusing on different materials and different strategies, but China is the first to produce a working industrial line and begin early deployments. That is a major advantage. The researchers also said something that caught everyone's attention. They claimed this is the first time optical quantum computing can be considered an industrial product. If this is true, then the field has officially moved beyond lab experiments. It means companies can start using these chips in real applications, side by side with GPUs and other accelerators. If things continue in this direction, the next few years could look very different. We may see hybrid systems where photons handle heavy workloads and classical silicon handles the rest. NVIDIA GPUs will not disappear, but they may not be the only choice for fast AI processing in the future. As energy costs rise and cooling becomes more difficult, companies will look for alternatives that offer more speed and use less power. This new quantum photonic chip from China is more than just a breakthrough. It is a sign that the global AI race is entering a new phase. Photonics and quantum-inspired designs may soon become the backbone of future data centers. The world is watching closely, and the competition is only getting stronger. Thank you for watching. Share your thoughts below and subscribe for more deep dive AI content.